addresses 5 primary pain points. And the one we're talking about today is the first one. It's the idle wait time here. So we want to have fast feedback cycles and we want to be productive. So the build and test accelerator so far that we provide in Gradle Enterprise consists mainly of the build cache. If you're familiar with the build cache, yeah, you can really speed up your builds by up to 90% for Maven and for Gradle. And today we're going to put that distributed testing on top of that to give you even more speed up in your builds to achieve faster feedback cycles. Before we do that, we're going to take a look at some existing solutions for speeding up test execution. The first one I briefly mentioned is build caching. So build caching is a feature of Gradle Enterprise. There's a remote cache built into Gradle Enterprise that you can use for Gradle and for Maven builds. Basically what it gives you, it allows you to cache the execution of a Gradle task or a Maven goal. So if the inputs of the Gradle task or Maven goal haven't changed and it has been run before, you can upload the outputs from the cache and you don't have to execute it again. So you save a lot of time. And that applies to any task. So it could be a compile task, for example, but it could also be a test task. The thing with test tasks and caching, you don't have to run the test task if nothing has changed, right? If all your code is still the same, yeah, no reason to rerun the test task. But usually you do make changes. What happened now? Okay, sorry. Yeah, so now we're back on the presentation. Yep, we are. So usually you do make changes to your code, right? That's why you develop software in the first place. So you end up having different inputs for your test task. And then that means you have to rerun the test task in that case. So build caching only has a limited benefit for testing in that sense, especially if you have lots of integration tests that basically depend on the whole system that you develop, and then you'll have to rerun them every time you make a change to your code. Another existing solution is called single machine parallelism, and that's a built-in feature in Gradle. It's controlled by a couple of flags, so you can enable with -- parallel project parallelism. That means that tasks in different subprojects in a multi-project build will run in parallel. By default, it's off. It's usually good that can significantly speed up your build, not just your tests. Another flag is max workers. In addition to parallel, it controls like the maximum number of parallelism that you can achieve on a machine, and it defaults to the number of processors or cores on your machine. So say you have an 8-core machine and you enable -- parallel, then up to 8 tasks can run in parallel. When it comes to testing, there's another very important flag on the test task itself. It's called max parallel forks, and it controls how many VMs are used to run your tests. So this could be just one, which is the default. But if you increase this, for example, you say you have, I don't know, you want to run 4 VMs in parallel, you can set it to 4, and then 4 test classes will be run in parallel. It's also restricted by the max workers flag. That's why it's also listed here. So if you only have, say, 8 cores, you should not run more than 8 VMs in parallel of tests, right? So that's kind of where that comes into play. Another solution is called CI Fanout. And here test execution is distributed by manually partitioning the test set and then running the partitions in parallel on several CI nodes. So it usually looks like this. This is a pseudo pipeline script. So you have some stage, it's called compile, where you compile all your test classes or your production classes as well. And if you have a build cache, you can store that in the build cache. So later stages don't have to redo those steps. And then in the next stage, which you can run in parallel, you will have different groups of tests running, which in this case are modeled as Gradle tasks. Could also be includes, excludes, something like that, right? And those stages would be allowed to run in parallel on different CI agents. So let's assess these existing solutions. Build caching is great in many cases, but as I said previously, it doesn't help you when the test inputs have changed. So especially for test tasks that can dominate the build time build caching is not always the solution. It might still help for the compile tasks and other tasks that are really intense in time, but it doesn't help for tests if you have to rerun them. You have to run them, you have to pay the price. Single machine parallelism is limited by the machine's resources the build runs on, right? You cannot scale beyond your cores. CI Fanout does not help at all during local development. It only works on CI. And it's really inefficient, in particular on ephemeral CI agents. So those are agents you start up for every build. You will have to probably download the Gradle distribution again, download all the dependencies again, maybe build everything, especially if you don't use the build cache, up to the point where you can actually start executing the tests. There's a lot of work that has to be done on each of these nodes that you fan out. And also it requires manual setup. So you have to think about this pipeline. You have to configure it on your build server. You have to think about test partitioning. How do we split the tests into equal groups? And also result collection and aggregation is something you have to worry about. So we would like to ask you the first poll of today. Which strategies to speed up test execution do you already use? Let me send that poll to you. There we are. So 62% of you use build caching. That's great, cool, good to know. About 60% use single machine parallelism, so just parallel or max parallel forks probably. And about a third use CI Fanout already, so that's interesting. So this seems to be a true problem for some of you. So and you have actually taken steps to address that.